Hello, everybody, and welcome to the Crypto Hipster Podcast. This is your host, Jamil Hassan, the Crypto Hipster, where I interview founders, entrepreneurs, executives, thought leaders, you name it, all around the world of crypto and blockchain. And today I have another amazing guest. He is the co-founder of Taraxa. His name is Stephen Pugh. Stephen, welcome to the show.
Thank you very much for having me, Jamil. Great to be on the show. Yeah.
You're very welcome. Very welcome. So I'll ask you first, kick things off, and I'll ask you, what is your background, and is it a logical background for what you're doing now?
Yeah, so I suppose it's somewhat logical. I was educated as an electrical engineer at Stanford University, a bachelor's and master's degree. So I do have a technical background, but my career hasn't been as an engineer. After I graduated, I did consulting and then I did a bunch of startups, but I wasn't sort of the primary engineer in those startups. So I had a more of a had an education in engineering, and my career had been more in business. I taught myself how to code when I was like 12, and have been really just kind of coding random stuff on my own for fun. Did a bunch of startups when I was actually in high school during the internet boom, actually, during the late 90s. So I've always had a love for engineering. I've always had a love for building things. I did multiple startups when, prior to Taraxa in Internet of Things, in mobile health. So not really a stranger to entrepreneurship, not a stranger to engineering. I just happen not to have an academic background in things like distributed systems, for example. So I had to read a lot of academic papers when I first got into layer one design.
Got it. I want to find out what Taraxa is all about, including what a block DAG is compared to a blockchain.
Yeah. Yeah. So Taraxa is interesting. We started thinking about kind of figuring out what we should do in Web3. Once I got convinced that decentralization is truly something extraordinary and that I wanted to be a part of it. So that was back around like early 2017, late 2016. So a little bit late to the game, right? Because I first heard about Bitcoin in 2013. Took me a few years to really catch on. And once we figured that out, we're like, what can we do, right? What is the most interesting and impactful thing we can do to kind of get into the space? And layer one was at the time a pretty obvious choice because, as we all know, Ethereum just came out and smart contracts just kind of came out. ERC20s came out, had the big ICO boom, and we all saw that the state of the art, right, at the time, Ethereum was not really that scalable. And for any kind of meaningful applications to run on top of a decentralized network, you need much better scalability. So that was really the entry point of how we kind of decided to build layer one for Taraxa. And at the time, we were searching for different types of architectures. So what kind of architecture would really work well for something that was scalable, but at the same time didn't sacrifice any decentralization or security, right? So Vitalik had that classic trilemma that he posed. So we said, this is often the problem that the first few iterations of a technology tend to be suboptimal, right? You see a lot of trade-offs, but really the trade-offs exist because you're at a suboptimal point. So it seems like whenever you do anything, you're sacrificing something else. And those trade-offs, in engineering, you always get trade-offs. But because you're stuck at a suboptimal point, you are trading, you can't really improve. So you need to kind of shift the paradigm and move it to a different place where everything just improves without trading off, because you're no longer stuck in a suboptimal location in the overall architectural design. So that was what we're looking for. And again, we read a lot of papers. And one of the papers we actually came across was this paper called Phantom Gold Stack. It was authored by Sompolinsky, Wyborski, and Zohar. So for people who know, Sompolinsky and Wyborski are two of the key founding members of the Casper project. So these are the people that actually invented the block DAG paradigm. And they have been, especially I think some Polinsky have been publishing very academic and well-researched academic papers with security proofs for many, many years. Like after Bitcoin came out, there wasn't really a lot of mainstream academic interest in this technology. And he was one of the few serious researchers that was actually looking at it. So he is very well known within the blockchain, the crypto circle, for the rigorous and just really high quality research. So we saw that paper. We read a lot of papers which had a lot of different things. We saw that paper, and it was like, wow, this makes a lot of sense, right? So block DAG, as it was described in that Phantom Ghost DAG paper, resides on a very, very simple concept, which is instead of just having one block added to the network at a single time, why can't we just add more blocks? Because the network actually naturally on single chain architectures, most of what you see today are single chain architectures, which is like Ethereum, like Bitcoin. They add one block to the system at a time. But in the network, more than one block is produced at a time. And all the other blocks that get produced are thrown away. So this paradigm, this block DAG paradigm just says, look, why don't we figure out a way to include all the blocks that are produced and we don't throw them away, right? Because there are many nodes on the network. Why not take advantage of the natural parallel processing that just exists naturally on a decentralized network? So the difficulty then becomes, well, if you include all these blocks, how do you ensure that ordering is secure, that you don't get reorganized, you don't get attacked, and that and that the network is still remains decentralized and secure. So this was the big problem I think block DAG solved. They had a few kind of very interesting examples. So in a single chain network, how do you increase throughput, right? So you can only add one block at a time into the network. And so if you keep that going, if you want to remain one block at a time, what you can do is maybe you can make the blocks really big, right? Just make the blocks bigger. Then maybe you'll get more throughput. Maybe you scale up. But the problem with much bigger blocks is that they propagate through the network much more slowly. So that creates a problem in which one node is much more likely to see a different picture of the network than another node. And when different nodes see different pictures of the network, they start building on different blocks. So they start creating these forks on the network. So not only are you not really increasing the throughput, you're also sacrificing a lot on the security because now you get a lot more forks, you get a much higher risk of reorganization and rolling back transactions. So increasing the size of the block doesn't really make a lot of sense because you're massively trading off security. Okay, so why don't you? Okay, so increasing the size of blocks doesn't really work. So why don't you just create a lot more blocks? Well, if you create a lot more blocks, you run into the exact same problem because at any given time, only one block can get added to the chain. So if you create a lot more blocks, then you just end up confusing more nodes, right? And you get the exact same problem where all these nodes are seeing different blocks, lots of different options at any given moment, and they're adding different blocks into the chain, creates more forking, sacrificing more security. So these are fundamental problems and challenges that single chain architectures run into. And it's extremely difficult to overcome them unless you change the fundamental architecture, which is turn this into from a single chain into more of a graph, right? You allow all the blocks to come in, be ordered according to a specific ordering mechanism. They actually described it in a paper called the Ghost Protocol. And that ensures ordering and ensures that there's not a lot of reordering going on. So when we read that paper, I think they just published it, and we said, wow, this is pretty amazing, right? And it looks like it just makes a lot of intuitive sense. They also had very rigorous security proofs, but intuitively, it just made a lot of sense. And there are a few open problems back in 2018 when we first saw the paper. And so we decided to say, hey, let's try to adapt this topology, this architecture into building really the next generation of layer one architectures. And at the beginning, when we started building this, the paper described a proof of work kind of a approach because it was trying to improve Bitcoin, right? So for us, we said, look, we wanted to build something that was more of an application platform or smart contract platform, like Ethereum. So that's where kind of our approaches diverge, I guess, from Casp. At the time, it wasn't known as Casp. I think at the time they were known as DAG Labs. So anyway, a lot of name changes. So we ended up building something that was intended to be a smart contract platform that runs applications. So from day one, we said it's going to have a virtual machine. It's going to be 100% EVM compatible just because the ecosystem out there, all the builders out there, the tooling out there are all EVM compatible. So if you made it EVM compatible, then builders will have a much easier time adopting your technology. They don't have to learn anything new. They just use the same tools, and it would just work. So it had to be EVM compatible. We wanted to be proof of stake, just because we thought that proof of work has its role. I'm not here to kind of slam proof of work, but it does create a ton of energy consumption because of the natural arms race nature, that of the hardware arms race nature that creates proof of work. So we said, look, I mean, if you want something that's more efficient, then you have to go with proof of stake. So this is why we ended up creating something that is a block DAG, but it's a proof of stake and also 100% EVM compatible. So this is Teraxa right now is the world's only proof of stake block DAG and 100% EVM compatible smart contract platform. And it's been quite a wild journey because we had to create a lot of innovations that didn't exist anywhere in the paper or anywhere else actually, in order to make sure that we ensure rapid convergence in the DAG. We made sure we were actually able to natively integrate a VM onto the block DAG while removing all the throughput bottlenecks. We had to add another layer of consensus on top of it to make sure that the security guarantees are not broken, while at the same time we can maintain high throughput. So we added a lot of we had to invent a lot of stuff in order to make sure that Teraxa as it exists today worked as intended without making any crazy decentralization or security sacrifices. Yeah, so it's been, like I said, it's been a wild ride. We started in 2017, 2018. We launched our mainnet in April of 2023. It's been running ever since.
So you had a 6-year, I guess, build process?
Yeah, we had a really long build process. The interesting thing is that at the time we were in touch with, obviously we were talking to a lot of other teams that are building layer ones. And one of the interesting things that was different from what we did versus what they did is that these other teams were much more, I guess, market minded, that they prioritized releasing much earlier. So we also, and then when they released an earlier product, it was kind of half broken or it didn't have like 80% of the features that it promised, but they got to market earlier and they just kind of kept building and kept fixing it as they went along. And we saw a lot of teams run into a lot of problems because it didn't take enough time, and they recognize that. It's not like they're trying to trick anyone. You make the trade-off, right? So we always thought that it's for layer one, you shouldn't rush it into market because there's like people's money on top of it, right? In the Silicon Valley ethos, you move fast and break things. If you move fast and break things on infrastructure technologies like layer ones, you start causing a lot of damage. So we had a small team. A lot of other layer ones also had small teams, but I think what made us different than them is we kind of just wanted to release something that was fully functional, fully featured, everything that we set out to do in the white paper, we wanted to deliver, and we just released something that just worked really well. And yeah, so I think that delayed us for at least several years. There was another reason why I think we were a little bit delayed. We had a fully functional product, a network by early 2022, which I think it's the same time I think Caspa launched. but when we try to say we want to do like a native token conversion, so kind of convert the ERC20 into the native coin, the exchanges that we were listed on said that they wouldn't support the conversion early because there's a long queue of people. You have to stand in line and wait for the conversion, and the wait time was like a year. So we were a little bit unhappy about that. But if you did a native token conversion and the exchanges didn't support it, that's a huge problem. So we kind of just, we sat around, we did like another audit, we did like a second audit, we added more features and did more testing throughout that year, and we launched, without incident in 2023. But if we didn't we didn't have to wait for the exchanges, we would launch, I think, early 2022. If we didn't insist on delivering the fully featured version, I think we probably could have launched in 2020 maybe. So anyway, so just again, different trade-offs, different decisions. We're ultimately, I think we're pretty happy about the product that we've released, obviously open source, because we still fundamentally believe that layer one needs to be stable, it needs to be secure, it just can't have any problems when you release it, right? So that kind of trade-off was something we weren't willing to make. Yeah.
So I just got a press release that popped up my desk 10 minutes ago, and it was on BlockDAG. So
Really?
yeah, it
From whom?
says I'm looking at it. It says Solana TVL and Aptos price surge as BlockDAG fuels DeFi boom. I don't know if that's you. That's going to be listed on all these exchanges, but I want to find out what what are the factors influencing your resurgence, and then what is your potential to reshape the nature of the whole entire Web3 movement?
Yeah, yeah. I think BlockDAG, as usual, kind of price action seems to drive attention, right? So as a builder, I'd rather not wasn't the case, but that's the case. That's how the market works. And I think the reason why BlockDAG gained a lot of attention was because Caspa had just an absolutely meteoric rise in its valuation from the time it launched in 2022. Basically, getting is worth nothing, worth zero, and then till today, I don't know what the valuation is, like 5 billion or something like that. So it would just went absolutely like sort of through the roof. And actually, this is very interesting. I always thought that people didn't care about tech, right? And maybe they don't. Maybe they only care about tech because of the price. I'm not really sure. The vast majority of people in crypto don't care or understand the technology. So at Taraxa, we didn't really spend a lot of time talking about technology. I think very early on, 2017, 2018, parts of 2019, we did talk quite a bit about the underlying consensus technology, but very quickly we tried to pivot into use cases. And at the time, we were very focused on enterprise use cases, as most of Web3 were at that time before DeFi came out. So we were always very focused on talking about how this could be used, all the use cases that could be possible. And I think when Caspa came out, and then we became aware of Caspa, I think maybe June or July of 2023. And there's a huge amount of interest in BlockDAG technology. So that was kind of coincidence because honestly, I've been kind of trying to keep tabs on DAG Labs, and then that company kind of disappeared. so I figured it died. I didn't know, and I had no idea that Caspa got launched from DAG Labs. So I thought that project died, but so I sort of lost track of it. And now there's like kind of a huge amount of interest in BlockDAG, and we've had some conversations with some of the founders over there at Caspa because I feel very fortunate to be able to talk to them because these are the authors of the original paper, right? So it's really, really cool to be able to talk to them. So there was a lot of interest, I think, in BlockDAG because of originally, I think, because of the price action. I mean, it's fine just because BlockDAG is actually superior technology. Like we've always said that it's the next iteration in blockchain or in decentralized networks, right? And it's just a natural evolution, right? You go from single chain into like a graph. It's a superset. It's not extremely accurate, but it's sort of like a more generalized version of a blockchain. So it's just better technology in every single way. And how I would see it, you already start seeing a lot of projects kind of very quietly starting to adopt block DAC like architectures. And I think these days, projects don't spend a lot of time writing out their technical papers. So it's hard to kind of tease out exactly what the architecture is. And we don't have time to like read through the code of all these new projects that are coming out. But it's pretty clear that there's recognition that this type of DAG topology is the way to go. I think some of the most dominant single chain topologies today, quite frankly, I think they're going to get phased out in a few. Maybe by the next cycle, they're all going to get phased out, and they're just suboptimal. Again, single chain topologies are suboptimal. They're just not that they're just not that great. They're just not that great, right? So I think DAG topologies, block DAG specifically, would be making quite a bit of a impact within Web3 as more and more layer one infrastructure start adopting either block DAG or something similar to block DAG. As of today, I don't think any other project really adheres or officially adheres to the block DAG paradigm like Terax. I mean, obviously Casper, right? They're the ones who invented it. But really, we're the only other project, I think, in the world that adheres this closely to the original paradigm. Other people, like I said, it's unclear, whether or not they just have their own version or whatever. But yeah, I can definitely see it influencing other projects, which is a great sign, right? We're in this space, everything we build is open source. We hope that the things that we build will have a lasting positive impact, to not just ourselves, but to the entire space. Yeah.
Got it. So let me make sure I can understand this correctly. And then I have a couple other questions too.
Sure.
Um, in the past, I've interviewed Hedera and the Graph. They're a graph, right? And then I interviewed, it was Internet of Things project back in 2021 or two that I interviewed. A popular one. They had a DAG architecture. How do you differ from the graph and the
Yeah.
IoT DAG?
Yeah. So DAG is a mathematical construct, right? It's it's not like it's like a data structure in math, right? It's not, just saying your DAG, it's kind of saying I'm making a round cup. Well, lots of cups are round. I mean, you don't own the circle, right? I mean, no one invented the circle. It's just like discovered. It's mathematics. So DAG is like that. It's a mathematical concept. It's a mathematical construct. And a lot of data could be structured in a DAG format. So block DAG is a specific way of organizing blocks, a specific way to drive convergence in ordering. So it's very, very specific. I think just because a project says it's DAG doesn't mean it's block DAG, right? So maybe they could have named it differently. They could have called it like something else that doesn't have the word DAG in it. Maybe then it'll be a little bit more differentiated. Yeah. So plenty of projects use some sort of graph in their data structure, in the way they organize their data on chain. But really, I haven't really seen anyone besides Casper, obviously, that does it exactly like the way that block DAG describes it. Obviously, everyone has trade-offs. The way this project does it is different than the way the other project does it. I think that's probably a little bit too much to dig into during this interview. But yeah, just because someone's DAG doesn't mean it's block DAG, right? So
Got it. So going back to 2017 and 18, I think it was more 17.
yeah,
We saw a war between people who were big blockers and small blockers, right? We saw that in the Bitcoin that maybe they really needed a hard fork, but they ended up with a soft fork and created Bitcoin Cash or SV. Like, And you were around that time. So what did you learn from that war between the Bitcoin, the big blockers and the small blockers and the Bitcoin wars? And
Yeah.
how did you make a difference in what you built?
Well, several things. I think from a high level, you start realizing that single chain architectures are kind of not going to be the future, right? Because the stuff that were being proposed to scale Bitcoin were just kind of very small incremental steps that had clear trade-offs, right? So if you wanted to, again, jump out of that, just drastically improve it, you have to jump out of that paradigm. Now, Bitcoin is revolutionary because it was the first one. It's just, there was nothing, I mean, there were one or two things before it that might have been similar, but it's truly revolutionary because it's really the first mass adopted, decentralized network. And the person, whoever he is, right, designed it and built it, obviously went with the most conservative design, which makes sense, right? Like when technology comes out, they tend to use conservative designs to make sure that it works and is secure. Right? Now, so that's the first thing that we really learn is that this architecture, this topology of single chain really is not the future. So you got to start looking for something drastically different, right, in order to scale. The second thing you kind of learn is that, and this happens, I think, in every single ecosystem, is that once they become big enough, they start to slow down in the way that they change. And it's natural, right? A lot more people are in it, a lot more financial interests are in it, a lot more stakeholders. Naturally, things slow down. It's like a company, a small startup moves a lot quicker than a large corporation. Right? It's the same idea. So that part of it is a little bit more difficult, right? It's a little bit difficult to solve, right? Because you want you want these networks to be decentralized. You don't want there to be like a dictator at the top saying, we're doing this today, we're doing that tomorrow. That's not how it really works. But the more decentralized it becomes, the more successful it becomes, kind of the slower it innovates. I don't really know that there is a solution to that. It's human behavior, right? It's not a technological problem, it's a human problem. And it hasn't really been solved over thousands of years of civilization. So I'm not really sure it's going to get solved here. The only way that I think markets solve this problem has been the same way they've solved this problem for God knows how long, is that the poorly performing networks, the ones that don't adapt fast enough, they die, right? And the new ones kind of try to take their place. And we see that happening all the time, right? In the market today, we see that happening. The networks that don't innovate, that don't catch up, they don't get as much traction. And after a few cycles, they kind of just, lay by the wayside and people kind of forget who they are. And that's just the way networks, or that's the way everything really works. And it's being played out obviously in decentralized world as well. So I think those are the two things that we learn, I guess. but the second one, not much you can do about. The first one really drives you to look for the next iteration, the next new thing that's really gonna happen. Maybe there's a way to foster a kind of aggressively growth-minded ecosystem, perhaps. I'm not really sure, but again, you know, some of the um, some of the more successful entrants after Ethereum have also beginning to show signs of ossification, right? They're not really changing. They're not really catching up. Not going to name any names, but just to say that what is winning in this cycle very well might not be winning the next cycle, just because we haven't seen them actually innovate, catching up to the latest innovations. Despite it's very paradoxical. These projects have so much money, resources, yet they don't really change, right? It's very, very paradoxical. But I mean that's just the way it is. The new comes in, the old moves out. So
Let's talk about the new, right?
yeah.
Let's talk about BlockDAG, and you conquer the scalability trilemma. So I want to find out what that is, and then how do you do that, and then how do you help DeFi or going to help DeFi meet its original promises?
Sorry, what was that last part?
How do you help DeFi meet its original promises?
Oh, okay, yeah. So how does this solve the trilemma? So I think at a high level, as I mentioned earlier, it's really at a very high abstract level, it's really about, kind of if you're drawing a curve, right? And you're saying, well, where's the maximum? But you're kind of stuck in like a little hill on the side, right? If you're stuck on a little hill, it seems like wherever you're going, it's going downward. So you're like, we're at the maximum, but then there's a much higher hill somewhere else. So single chain is kind of stuck on that little hill, and they don't see that there's a higher hill where you don't need to make any trade-offs and just kind of improve everything at the same time. So I think I talked a little bit about the security trade-offs for single chains. If you want to increase throughput, increasing bigger blocks or adding more blocks onto a single chain paradigm just sacrifices security with little to no gains on throughput. So that's the fundamental limitation of single chain architectures. On a block DAG, you're naturally allowing more nodes on the network to contribute multiple blocks at the same time, or they're asynchronous. It's not even at the same time, just contribute into the graph, right? Adding more transactions into blocks and adding those blocks into the graph very naturally, asynchronously, and just having everyone contribute simultaneously. You know, do you want one node to be contributing at any given time, or do you want 10 nodes or 20 nodes to be contributing at any given time? No brainer. Obviously, the more, the better. With that comes the complexity of, well, how do you keep ordering straight? And that's a big kind of challenge, right? So with a single chain, it's pretty obvious, right? Just go one after the other. There's no confusion about ordering. But on a graph, it gets a little bit harder, right? So how do you things get ordered if everything's in like a big kind of mesh? So then you start getting to the idea of I call it a popularity contest, right? So here's a popularity contest. When you create a block on the DAG, you say, when I'm creating this block, at the time of me adding this block into the block DAG, here are all the other blocks I see that are right before me, right? It's like kind of standing in line, right? So imagine you're standing in line and you're like, well, who's in front of whom? Because it's like it's not a single line, it's like a big crowd. All you're doing is you're saying, everyone said, well, when I got here, these five guys were in front of me, right? Right. And then and then another guy came here and said, well, when I got here, these other four guys were in front of me. So if you start putting that together, after a while, you get to see, well, if he says these five guys in front of him, that guy says these three guys in front of him. I'm not going to go into the math, but after a while, you can say, okay, then we can actually start doing some ordering out of this, right? Assuming most people are honest and they're not lying. So that's how you do ordering. That's kind of the ghost rule, which is weights. It's a system of weights, add them together, depending on who sees whom in front of them when they're creating those blocks. So that's the way to really solve the ordering problem. We also have this idea of the most popular block, which is another extension of this. Sort of like, of the three people in front of you that you see, who is like the person that you think everyone else thinks is in front of them, all right? That kind of thing. The metaphor kind of breaks down a little bit when you start getting too deep into it. But it basically sort of who's in front of you and who do you think the most popular guy that's in front of you is, right? And if everyone kind of does that, and then you have this idea of building kind of like a path that links up the most popular people, the most popular blocks in the DAG, and that helps you to drive ordering convergence across the entire graph. So this is a critical problem that had to be solved. I think in the original paper for Phantom Ghost DAG, they described a different way of doing it, a slightly different way to the weighting system, the ghost rule is still the same, but to drive rapid convergence, they had a different way of doing it, which actually was very slow. But later on, as I talked to the Casper team, it was a really hard problem to solve. We actually didn't solve it, so we invented a new way to do it. And then they kept going, and I think they actually solved it. And honestly, I hadn't had time to kind of dig into their solution. But in the end, what you're trying to do is you're trying to make sure that there is ordering established, and that you want the ordering to not keep changing all the time. So that's what we call rapid convergence. Like the ordering needs to kind of get set in stone very, very quickly, so that some attacker can come in and just mess up your ordering like arbitrarily, right? So that's how it really sort of ensures that there's still security, right? There's no reorganization. It's very hard to attack, and that there's still decentralization. There's no like sort of crazy like pick a leader to do something. A lot of, I think, proof of stake consensus has this kind of issue where they're kind of picking a leader, and you know who that leader is. So just attack the leader, right? I mean, pretty simple. So these are kind of issues that they have. But this one, all the people are randomly producing these blocks at any given time. You have to attack the whole network, right? So no decentralization sacrifices, no security sacrifices. But at the same time, clearly you get a massive throughput upgrade just because there are a lot of nodes adding blocks into the DAG simultaneously. So intuitively, this is a way you can start understanding this. It's kind of, lots of people working together and using kind of who's in front of me, kind of a analogy to determine ordering. And that it just works really well. And it's very elegant. I mean, that's one of the reasons why we just absolutely love that paper when we read it. It's so elegant. Like it's so simple. It just makes sense, right? So that was very, very interesting. So how does this help DeFi, right? So DeFi obviously is interesting because nothing generates tons of transactions on chain like DeFi does. I don't think there's any other class of applications that makes use of these decentralized networks as much as DeFi. So I think there's several things that can really help DeFi. Number one, obviously the scalability. So you can actually bring larger portions of the activity on chain, right? Obviously faster, cheaper, everyone likes that. And so it can really, really help to scale up DeFi. Another really interesting characteristic of block DAG is that it has this property of instant transaction inclusion, right? So this is very, very interesting. So as soon as a transaction gets sent into the network, it's almost instantaneously put into a block just because there's so many people see it, and one of them is going to put it into a block, right? So the problem with kind of front running, right? I think other people call it like MEV, or there's kind of different names for it. But the idea is that you do a DeFi transaction, there's a bot kind of, watching all these transactions. They're like, wait, that one, I think I can take advantage of. And they try to kind of sandwich attack your transaction, making your transaction more expensive. They're basically siphoning off of you, right? Front running, lots of different names. Now, the key to front running is that they have to be able to see a long queue of pending transactions that haven't really made it into the block yet, right? By the time they've made it into a block, it's too late. Like it's way too late for you to attack it because it's very hard to mess with the ordering once it's in the block. So because the block DAG kind of paradigm helps you put these transactions into a block almost instantaneously, that means that there's not a very big kind of mempool, or not a big like kind of queue where people are kind of waiting in line. So right away you're eliminating the you're eliminating like the pool from which the attacker can select like victims from, right? They don't even see anything in the pool. So what are they going to attack? They're not going to be able to attack anything. And by the time they hear about a transaction, there's like a 99% chance it's already in a block anyway. Then it becomes just way too expensive to attack. It's not worth it anymore, right? So it also, just by this very nature of this block DAG, it can help really to solve this problem of front running. I think there are a lot of other DeFi protocols that are deployed on single chain architectures that are doing a lot of crazy kind of technical jujitsu to overcome this front running problem. But the problem actually originates in the underlying layer one's architecture. So this is something that's not really well known, not really widely understood, but it costs a lot of people a lot of money every single day, actually. So I think, again, with a better architecture, you're actually able to make a lot of advancements and simultaneously without really making a ton of trade-offs. This is when you have like a fundamental upgrade, right? So that's, I think block is this paradigm, this architecture is really going to be a big deal. If not this cycle, then the next cycle. It's going to shine through at some point, right? So.
I sounds like to me. I agree, and I'm glad. I'm glad you're doing the ordering on the technology level because I'll be honest with you. There's a lot of four-way stop signs in my town, and people don't want to go in order. So they want to shoot. They want to shoot before you, go before you. But I want to thank you very much for speaking with me today. I'm going to follow you guys and probably buy some block dag if I can. You know, and I'm looking forward to this next year, this next cycle. So I have one last question. How can people find out more information about you, about Taraxa, about BlockDAG? How can they do that?
Yeah. So first you can come to Taraxa.io and check us out. And there's lots of very interesting information just on the main website. If you go to visualizer.terrasa.io, you actually get a real-time visual representation of the entire network, which looks really cool. I'm a little biased. I look at it for 30 minutes at a time. It's so mesmerizing. It's very interesting. You'll see that it's just very, very different than all these other architectures out there. And if you want to dig into more of the consensus, right, just go to terrasa.io/consensus. You can read all the articles about all the stuff that we just talked about. Yeah. And if you want to find out more about Terrasa's ecosystem, you go to terrasa.land and all the ecosystem projects there. We have DeFi, we have DEXs, stable coins. There's a lot more stuff getting in the pipeline. We have a big social AI ecosystem that's coming out very, very soon. So yeah. Give us a follow on Twitter at Terrasa_project. So
Awesome. Thank you very much for your time today.
thank you very much, Jamil. Great to be here.